Hi everybody, welcome back into my YouTube channel, Deasy Gemstones, and this is the Colored Gemstone Academy. Now today, we're talking about lesson 6, which is part 4 of the 4 C's. If you remember the last 3 lessons, we talked about the 4 C's. So there was the color, the cut, the clarity, and the carat weight. So today, we talk about part 4, and that is indeed the carat weight. So first of all, you'll notice a little different setting today. I have a table in front of me because I'm going to have some real life examples about carat weight, because remember, as the name implies, carat weight is talking about the weight of the gemstone, not the size of the gemstone. Before I delve deeper into that, let's talk about the word carat itself. It is spelled C-A-R-A-T. Now those of you who have maybe enjoyed jewelry for years might notice there's another carat that is spelled K-A-R-A-T. To make it even more confusing, suppose you had like a 14 karat citrine set in 14 karat gold. Well, now we're totally confused. And to make it even more confusing than that, there are some countries that spell the K-A-R-A-T the same as C-A-R-A-T when they're talking about 2 different things. But let's first of all talk about the carat with the C. It is the weight of the gemstone. Whereas carat, K-A-R-A-T, is talking about the purity of the gold. So in other words, you can have 10 karat gold, 14 karat gold, 18 karat gold, or pretty much pure 24 karat gold. And that's talking about the purity. 24 being pure, 14 being 58.5% pure, 18 karat being 75% pure. So that talks about the purity of the gold. Now the carat, C-A-R-A-T, is talking about the weight. So where did that name come from for carat weight? Well, actually, if you go back in time, the simplest scales, now this is a gram scale that I can make into a carat scale, and that's something that almost every gemologist is going to have on hand. But back in the old days, they would have a simple lever. They would have something on one side and try and balance it with something on the other side, and that was how you determined the weight of an item. What they used back then, there was something that was considered to be very uniform in size, and it was a little seed in a carob. So a carob seed was pretty uniform in size, so they would drop a number of those seeds on there and put the gemstone on the other side, and they came up with a scale that said 100 carob seeds was equivalent to 1 carat gemstone. So basically, what is it in today's terms? Well, 1 carat is equal to 200 milligrams of weight. And I'll tell you how you can use that to figure out the weight of stones sometimes if you get the gram weight and you don't know what the carat weight is. So that's how we got the terminology of the carat from the carob seed. Now, as I said, it is all about the weight of the item and not the size of the item. So every single gemstone is going to have something that is called a specific gravity. That is the density or the heft of that gemstone. Now, specific gravity is actually an equivalency to 1 gram of water. So they're taking an item, they're comparing the weight to that to an equal volume of water. For example, the specific gravity of water would be 1. That's the standard. The specific gravity of a sapphire would be 4. Now what does that mean? That means if you could fit a cup of sapphires and eliminate all the space between it, and you weighed that, it would weigh 4 times as much as that water. Okay, now I know what you're thinking. Why do I care about all of that? Well, I'm going to show you some real examples of things that might look very similar in size but will have vastly different weights. So in this hand, you're looking at an abalone shell. An abalone shell has a specific gravity as 1.3. This one, the labradorite, has about a 2.7, so about twice the weight for the same size of stone. So when I put it on the scale, you'll see right there, when I put the abalone shell on there, that comes out at 19 carats. And you can see it settling onto that weight right now. Now I take that similar stone in shape and size and I put it on the labradorite, and you'll see it settling in at 81 carats. That's more than 4 times the size of that. Here, I'll give you another example. We'll go with a little bit of a smaller stone. Here's another abalone shell, but it's cut in a cushion shape. Again, still a 1.3 in your specific gravity. And then I'm going to compare that with this citrine, which appears to be smaller in stature to the abalone shell. So we put the abalone shell on there, and that's coming in at right about 5 carats. So we'll take that one off. We put on the citrine, and that's coming in at 11, more than twice the carat weight. Well, the specific gravity of your citrine is 2.65, and your specific gravity of the abalone is still 1.3. One last example, not to confuse you, but I'm going to give you 2 stones that appear to be pretty much the same size, the same thickness. And again, it's another labradorite stone. You can see that labradorescence. And then you're going to see this is a Larimar that comes from the Dominican Republic. So I place this one on the scale, and that one's coming in at 269 and a half carats. And then we take that one off, we put on our labradorite, and 303 carats. Yes, even though it looks a little thinner, these are almost the same specific gravity. So you can see how their weights came out very similar as well. So the carats, remember 200 milligrams is equivalent to 1 carat of gemstones. But we're going to talk next about some of the practical applications of the weight and the size of gems and how that works in real life. Okay, so I said I would give you some more real-world applications on explaining what the specific gravity means. One question I always like to ask is, what weighs more, a pound of feathers or a pound of bricks? Obviously, that is a trick question because they both weigh a pound. Perhaps the more important question would be, which one is bigger, a pound of feathers or a pound of bricks? Remember, the pound of bricks is very dense, so that would have a higher specific gravity. The pound of feathers would be bigger, almost probably like the size of a smaller pillow, which would be much larger than the brick. So the number with the smaller specific gravity will be the bigger of the items in appearance. So one practical application of this is if you want to buy a pair of earrings, and you want those pair of earrings to be big, but you don't want them to be too heavy, well, you'd want something like a mother of pearl, something with a 2.7, or that abalone shell with that 1.6 specific gravity, because you could wear a much bigger earring than, say, something like a hematite. Now, hematite is 5.2, one of the heaviest and densest gemstones that you can find. Another thing that I use as an example, a practical example. If you've ever been a fan or watched the shopping channels and you wanted to get a ring and they gave you a choice of 5 different gemstone flavors, like the amethyst, citrine, blue topaz, amethyst, and peridot. Well, you would notice that all of those stones would appear to be the same size, but they would not be the same weight because they all have different specific gravities. Now, one of the things that you have to keep in mind when we're talking about carat weight, if all other C's are considered equal, like the similar cut, similar color, similar clarity, well, obviously the bigger carat weight is going to be more valuable, because when you're buying any gem rough, you're paying by the pound or the kilo. So that's why that word that I brought up in a previous lesson, that yield, becomes very, very important. How many carats are you going to be able to get out of that kilo or that rough? But something else to keep in mind. Some gems naturally occur in bigger crystal sizes than others. For example, if you wanted to get a ruby and you had a great clarity, great color, and a 1 carat ruby, that would be a very expensive purchase. However, if you found the same clarity, the same color, and you found it in a 2 carat, it wouldn't be twice as expensive as at 1 carat. It might be 3 or 4 times, because it's rare to get that kind of crystal size in a ruby or a diamond or a sapphire. Now, conversely, if you're looking at something like an amethyst. Now, amethyst is one of the more valuable members of the quartz family of gemstones, but it's not uncommon to find crystal sizes of amethyst that are much larger. Now, a 10 carat amethyst will be more valuable than a 5 carat, because it's, if everything else is equal, because it's 10 carats, twice the weight. However, your price per carat wouldn't be such a big jump as it was with the ruby. You might pay, you know, $5 a carat for the 5 carat stone, and maybe $5.50 a carat for the 6 carat stone, something like that. So it's not the same for every single one of those examples. Okay, so we're coming down the home stretch now of our lesson on carat weight. And what does all of this mean when it comes to a gemologist testing a gemstone? How do we determine what a gemstone is, and how do we determine what its specific gravity is? Well, there are a lot of different aspects to a gem. We talked about chemical composition in the past. They actually have machines that could take a sophisticated test and tell you what the chemical composition is, or the cubic structure of that gemstone, because every gem might have a different crystal structure, not cubic structure, crystal structure. What is a hardness? We talked about the scratch test. What is a toughness? We talked about what that means. But when we get into, and then like a refractive index, that the sparkle of the stone, there's a refractometer where you can test that to identify what that stone is. How can we use specific gravity, that heft we've been talking about, to actually test the specific gravity of a gemstone? Well, actually they have something called heavy liquids. And basically we talked about how the water has a specific gravity of 1. Well, they make these other liquids with a 1, a 2, a 3, a 4, a 5, and so on, and they're called heavy liquids. And basically, each of those liquids would be a little bit denser than the one that was previous to that. So the way that they use that for testing is you take a gemstone and you place it into that liquid. And it's either going to do one of a couple of things. Number one, it might sink very, very quickly. Number two, it might sink very slowly. Number three, which would be the ideal, it's going to suspend, probably somewhere right in the middle, not going to go up or down, or it's going to actually bob up to the surface. And that's how you know when you get it in between like a 2 and a 3, then it's going to be somewhere, that's going to be what the specific gravity number is. So there is a way to actually test that. But I want to give you one more, actually 2 more, interesting examples of how we use this specific gravity examples and how we test a gemstone. One I remember, I'll never forget. I was in Tucson and I met a gentleman from Brazil, and we were talking about a purple garnet. And back then I think they called it the Brazilian plum garnet. And he was telling me about how that was discovered. Basically, there was a hunter who was a hunter that uses a slingshot. And of course, you know that in Brazil, amethyst is very, very prevalent in the country of Brazil, especially in this particular area where he was hunting. And he picked up some rock and he saw that it was purple. And because he's so familiar with amethyst, he felt, wow, this feels a little heavier than what amethyst usually feels like. So he had it tested in a nearby town and found out that it was in fact garnet. Now let's go through what that test probably included. So we talked about chemical composition. If you're looking at an amethyst, chemical composition is silicon dioxide. Well, the garnet is an iron aluminum silicate. Okay, so there's one strike right there. Crystal structure. The crystal structure of an amethyst is trigonal. The crystal structure of the garnet is cubic, just like I showed you that diamond where a garnet was growing inside. They're both cubic structure. That's a second strike. Number 3, hardness. The hardness of an amethyst is about 7. Hardness of a garnet kind of ranges between 7 and 7.5 on the Mohs scale of hardness. Now, refractive index. You put it on the the toughness, kind of similar there. Refractive index, you put it on a refractometer. The amethyst comes in between 1.54 and 1.55. And then you put in the garnet on that. Again, it's much higher. Remember, we have diamond. You have, I'm trying to blank on it for sparkle. Anyway, third is the garnet. Garnet is 1.76 to 1.83. And then you get to the specific gravity. The specific gravity of an amethyst is about 2.65. Garnet, 4.0. So that kind of tells you again how that practical example, this feels too heavy to be an amethyst, do all the tests, and sure enough, it turned out to be a purple garnet. Now, again, I've told you in the past, would I pay a premium for a purple garnet over an amethyst? Probably not. That's just me. That's my own... zircon was the word I was searching for. The zircon is next to the diamond, and then you have the garnet in terms of the refractive index. But I'll give you one last example, which is really interesting, and we just talked about the heavy liquids and how you test the stone. Well, remember that we said water is a 1 on a specific gravity. Amber, of all the gems I deal with, is the lowest at somewhere between 1.05 and 1.09 for amber. What that means is you don't even really need a heavy liquid to test an amber. But there's a very interesting test you can do with amber to see if it is genuine or it is imitation or it is not. And basically, amber will float in a solution of salt water. And I can show you some picture examples of that where you can see a necklace floating in salt water. So you know that that is actually genuine amber. And the practical application of that is when they're going to the Baltic Sea to try and find amber, it generally washes up on shore. And the reason is it will float on that salt water. So a lot of times out there, they might take a little boat out in the water and take a rake and disturb the floor of the water beneath them, so that if there's any amber there that they dislodge, it will float and then just wash up on shore. And that's really how they mine for that amber, is they're seeing what's washing up on shore. Well, that's going to finish this final lesson of the 4 C's, the color, cut, clarity, carat weight. This is the carat weight, and I hope you enjoyed it. We'll see you next time. But that's pretty much all you really need to know about carat weight as the 4th C, and most importantly, how it affects the value and what are the practical applications of the weight of what you're wearing, for example, in a pair of earrings. So that's going to conclude lesson 6, which is part 4 of the 4 C's, and that is the carat weight. Thanks for watching. If you like what you're seeing, please hit the subscribe button. Also, right next to that is a little bell icon. If you click on that, you will get notified when the next lesson comes, which will be 1 week from today. Thank you so much for watching, and see you next time.